Hello all. In this talk, I'll present a voice-based technique to edit dictated text eyes-free. Our phones are awesome, but they keep our hands and eyes busy and our heads down. So how about for our on-the-go text-based needs, be it texting, browsing the web, or replying to emails, we could do it eyes and hands-free, just like this.
Our trip to Bali was amazing.
Was fascinating.
Our trip to Bali was fascinating. Although the weather there was as hot as it was humid, it didn't.
Hot and humid.
Although the weather there was hot and humid, it did not stop us.
This was a demo video of our system, by the way. Text generation with speech is fast and convenient, but editing the dictated text with speech alone is a difficult problem to solve, even more so eyes-free, because editing is a spatial task, so our work focuses on editing dictated text. First, we wanted to understand that without any technical limitations imposed, what is the most natural way that users correct a piece of text using speech. So we conducted a formative study with 10 participants and found that 94% of the time, users exhibited one of two different correction behaviors. One, using commands for correction, we refer to this as commanding, and the second, speaking over an erroneous part of the text to correct it, we refer to this as re-dictation. Let's see an example. Say the user wants to insert quick brown before fox in the incorrect sentence. They did it either using conversational styled commands like could you please insert quick brown before fox in the sentence, or simply by using a canonical form like insert quick brown before fox. With re-dictation, to correct the same incorrect text that we saw in the previous example, users simply re-dictated an erroneous part with the intended correction. As to how many words the user would say to make a correction completely depends on the user. For example, the user might say, quick brown fox jumps over the, or quick brown fox, or fox jumps over, or simply quick brown with the intention of inserting it before fox in the incorrect sentence. So the system needs to figure out how to align the user correction, that is, how to align the tokens from the user correction as either replacements or insertions into the incorrect text. For both these techniques that we had identified in the user behavior, we designed their actual system implementations. To design the commanding technique, we used Google's Dialogflow, which allowed us to support, besides canonical commands, also conversational style commands. For this, we trained a hybrid classifier by hand labeling 1005 training examples for 10 different correction intents. And for the re-dictation technique, we computed the similarity between the incorrect text and the user utterance. Prior research suggests that when a previously dictated text is later corrected, the correction often shares similar elements with the original text. For example, fox jumped over can be corrected by saying jumps, which is morphologically similar, or leaps, which is semantically similar. Or maybe the user says something that is meant as an insertion, so there's no similar element in the user utterance. For computing similarity between the tokens of the user utterance and the incorrect text, we checked if the tokens share the same word stems or lemmas or the same sense relations. The matching tokens from the user utterance were then used to replace their matching counterparts in the incorrect text. And then to determine where the non-matching token should be inserted, the computation was done by consulting a language model. So now that each technique was implemented, we wanted to compare the two techniques to understand the pros and cons of each technique and how they allow the user to make corrections efficiently. For this, we ran a controlled user study where 16 participants used both the techniques to correct texts that were embedded with either one or two word errors arranged in different levels of complexity. What we found was that both commanding and re-dictation had their own strengths. Complex corrections were way faster using re-dictation, and also the participants attributed a sense of naturalness to using the re-dictation technique, whereas 1 to 2 word simple deletions were faster using commanding, and in general, commanding gave the user a sense of being in more control. Based on these observations, we proposed a system design where the user could correct using any technique they preferred without having to switch modes. So in effect, the users don't have to think in advance which technique they would be using to make a correction. Let's look at an example.
The first one was kind of in the middle of a city and it was very, very busy.
The first one was in a city.
The first one was in a city and it was very, very busy.
Delete very.
In a city and it was very busy.
So in conclusion, Re-Dictation is faster for longer and more complex corrections, while commanding is useful for simple changes, especially deletion. And secondly, the effectiveness of our proposed technique also extends to systems that offer visual feedback. And this was validated by editing text on smart glasses, which was presented in our Chi 20 paper, iDeter. And with that, I conclude my talk. Thank you all for being here.